Welcome to this particular module. Now we are also in between our theory classes, we are using some experimental class, right, and today we will show it to you how to install a oxygen plasma system. Now this oxygen plasma system is a system which uses, as its name says, oxygen. It uses a vacuum and creates a plasma, and this system is used for bonding PDMS with your silicon or PDMS with glass. Now I have already discussed that there are different kind of bonding methods. One is silicon to silicon bonding, other is silicon to glass bonding, other one is glass to PDMS bonding. So when you have PDMS is used for creating microfluidic chips, right. So today we will show from the installation side that how to install an oxygen plasma system, and when you use oxygen plasma system, you have a you can tweak the power, you can tweak the pressure, and you can tweak the time. So three things you can edit or you can change it, and depending on your application, this time variation, pressure variation and power variation have to be taken care. We will see by taking an actual example of microfluidics chips, and at that time I will explain you where exactly we are using this particular system. Today you focus on the lab class, and I will see you in the next lab module, which will be on some other experimental class. Till then you take care. If you have any question, you ask us through NPTEL forum. I will request now my student Anil to take that particular lab class where we will show you the oxygen plasma system. Bye.
Hi everyone, welcome to this module. Today it is a very interesting module. We have planned to show you installation of a very useful equipment that is used in a clean room. We have just opened the carton for the oxygen plasma system here. So oxygen plasma is a very multi-purpose system that can be used for surface activation, surface cleaning. Let us say you have a substrate or a glass substrate, you want to clean it. So oxygen plasma can be used for that. It is also used for surface enhancement, surface activation, in order if you want to coat antibodies or other materials on top of glass. Another important use of oxygen plasma system is to bond PDMS membranes to the glass substrate. So let us say if you are making microfluidic devices and you have patterned your electrodes or sensing material, sensing layer on a glass substrate, and you want to overlay a microfluidic channel on this glass substrate, how do you attach this microfluidic membrane, which is more often made using PDMS, onto this glass substrate? How do you attach those two, or how do you stick those two together? So that is usually done in the most efficient way using an oxygen plasma system. It is called plasma bonding. So we keep the layer of PDMS on this glass substrate, and then we keep it inside the plasma system, and the two layers bond. So we will be showing you a bonding process eventually, but first step what we are going to do is we will actually open up this carton and we will set it up here, so that you know how, when you set up a clean room, what are the processes involved, what are the things that you should take care while you set up a system. So this main box here is the chamber of the plasma system. There is this is the chamber, we will be showing it to you. This is a cylinder, this is a pipe that will be connecting the vacuum system to this chamber. So vacuum system is also here next to it, we will show it to you, it is there inside. Then another important thing that we need is an oxygen cylinder, which will also be there, we will be connecting and showing to you. Oxygen cylinder, vacuum chamber, a vacuum system, a chamber for creating the plasma, are the main components of an oxygen plasma system. Now let us dive into the installation, and then I will run you through it. So we are setting this thing up. So the chamber is there, we have just opened the bag and kept it now. You can see how a little bit sophisticated it is. We will tell you what each port does in due course of time when we actually show you the bonding process. So now as you observe, they have not actually gowned or they are not wearing sugar, because right now we have suspended the activity of the clean room because we are installing an equipment. So that is the protocol. When you are installing equipment, you actually suspend all functional activity in the clean room. Then you install it, check everything, and then restart all the cleaning process, and you again follow the protocol of gowning and coming in. So that is the next one there is the vacuum system. So he will connect the vacuum system to the chamber. So this is an oil based vacuum system. There are oil-less vacuum systems also. So as you have seen, we were trying to assemble the system. We have now assembled the plasma bonder system, and this is the main unit. This is the vacuum pump, and we have the oxygen cylinder behind me. The blue tube that you can see here is the oxygen supply that is going connected to the backside of the main unit. Okay. Now what is this? I told you that plasma cleaner or plasma bonder is used to clean the substrate, activate the substrate, surface modify a substrate before coating and all. It's a standard material processing technology. It is also conventionally used in biomedical devices, especially in microfluidic devices, to bond channels, micro channels made with PDMS onto glass substrate. This I had already told you before. Before I get into how this system is, how does it operate, and showing you a live demo and all, you need to first understand what is plasma. Okay, this, as you know, is oxygen plasma. So, but what is plasma? Plasma is any gaseous substance. Okay, it can be the air which has all the constituents of it, nitrogen, oxygen, argon and all, or a particular gas, let's say oxygen in this case. Oxygen that is in the plasma state. So what is plasma state? It is rich in, so in a normal gaseous state, the gas has only molecules, okay, the oxygen molecules, O2 molecules will be there. Now instead, in the plasma state, when you apply any electric field or RF energy, in this case we are using RF energy here, RF is a radio frequency energy, the gaseous mixture gets ionized. When I say ionized, what it means is that the potential is so high that the electrons in the molecule, the electronic cloud in the molecule gains enough energy to escape the attraction of the nucleus, and they enter the common space between the molecules, and thus the whole confined volume of the gaseous mixture gets charged with ions, with electrons. There is a lot of things that happen in a plasma. The electrons will be there, charged ions will be there, molecular ions will be there, atomic ions will be there. When I say atomic ions, it is the O2 with the energy becomes OO atoms, and those atoms also get ionized. Okay, so the atomic ions will be there, molecular ions will be there, moving electrons will be there, normal oxygen molecules will be there. It's a mixture of lot of entities. Okay, such a mixture is called plasma. So it is actually quite active. Such a plasma system is quite active, and if you place some substrate on it, these free moving electrons and atoms have the property to modify whatever substance is in it, in the environment of the plasma. Let's say I keep a glass substrate. If there are some impurities on top of it, this plasma will actually, because of so much things that are there in the plasma, it will go onto the surface and clean the glass slide. So that is what happens. It's in a very common way. That's what a plasma system does. So we have oxygen plasma here. Okay. Another thing is, when I tell about plasma, the biggest thing that anybody who has studied science in at least till class 10th or 12th that comes to their mind is that color. So plasma has a unique color for different properties. Let's say argon plasma, oxygen plasma. If you make plasma out of different entities, they will have specific color. Okay, so oxygen plasma has a kind of pink color. We will be creating plasma here today. It will be very interesting for you to watch. We will create plasma today. How the process and all we will see. So the plasma has a unique color. Why does different materials have different color? This is because, in a very crude way I will tell, there are a lot of processes that are happening that emits this color. But in a very simple way, if you break it down, I told you that we are applying high potential or RF energy to supply that energy, to transfer that energy onto the oxygen molecules, the electrons in the oxygen molecule, right? So the electrons escape. It's a continuous process of giving energy, releasing energy, and all these things are happening. So the electrons escape the outer nuclei, they go out, so that they have gained energy. But after some time, they lose energy and they come back to the ground state. In this process, they release energy. Okay, that is h nu, you know, right, from Planck's theory and all, hc by lambda. So when this movement to a higher energy state and coming back to a lower energy state happens, this energy is released usually in the form of visible light. That light is what we see as a plasma's color. So how is the plasma color different for different materials? This is because each molecule has a different radius. Radius in the sense the atom itself has a different radius. The nucleus, I mean not atom, the nucleus itself has a different radius because nucleus consists of different number of protons and neutrons for each atom. Oxygen has some defined amount. Oxygen atom is a bigger atom than, let's say, hydrogen atom, and the oxygen molecule is even bigger, and there is an electronic cloud surrounding it. So the energy with which the oxygen molecule or the oxygen atom attracts the electron and keeps it within its control is different from how a hydrogen atom keeps its electron within its control. So that energy is fundamentally released as a light, right? How I told you before. So because of the difference, let's say for hydrogen, let's say it's I can't remember the exact number. Let's say it's 10 electron volts in hydrogen, and if it's, let's say, 40 electron volts in oxygen, the electron that is excited and comes back to the ground state will release more energy in the case of oxygen than hydrogen because of this binding energy. It's called binding energy because this binding energy is more in oxygen. Because of this, as you know that if higher energy is towards the ultraviolet range, Hc by lambda. So when lambda is less, the energy is more. If you take the visible light, your red is towards the infrared spectrum, which is higher wavelength, and your ultraviolet spectrum, which is to the left of your visible spectrum, is the higher energy, lower wavelength range. That is why, because oxygen plasma, it's around pinkish in color, it is more towards the bluish region than the red region because it is of little bit higher energy. So if you take another material, you make a plasma out of it, it will have its own characteristic color. So you might be thinking why we are going, before you understand any system, especially systems that deal with vacuum, you should understand out and out the basics of whatever components are there in the system, even if it may not be required for your day-to-day operation with the system. This is because you should be able to troubleshoot if some issue comes up, that this is the reason behind this happening, and you should be able to fix it. And these are all very safety regulated systems. You have to be very careful in handling them, and we are handling oxygen also. It is explosive gas, so you have to be extremely careful while handling, and with great responsibility. This is also a power, like you tell in Spider-Man, with great power comes great responsibility. This has a very powerful system. We can lot of uses, but you should handle it with care. One part of handling it with care is understanding what is going on. You are not, let's say if you are handling an equipment, there are two ways of handling one. Somebody can be trained to handle an equipment, they will be a technician, they might not know exactly what is happening, or you can be a scientist who is handling the equipment and you know exactly what is happening, and you will be able to even suggest improvements in how the equipment is designed. That is how fundamentally throughout history new systems have been developed. Okay, this oxygen plasma has become a system like this after the pain and brainstorming of a lot of scientists and technicians. Everyone has contributed. So technicians would contribute to how easily they are able to use an equipment, how intuitive the controls are. Those things they give feedback. A scientist would give feedback in how you can improve the system, how you can improve its range of operation, how you can improve its versatility of operation in what all fields you can apply. So this is how systems get developed. So that's the overall idea about the plasma system, correct? Now coming to workflow of how we test this system, I told you that this is an oxygen plasma system and we have a chamber. I will show you all the things later. Plasma will be created in a chamber which has a definite volume. Now when you open a chamber, it will be filled with normal air. Our normal air, which has all nitrogen, oxygen, argon, everything. Now it is very difficult to control plasma and control the extent of etching or cleaning that it does if you try to create plasma from normal air. And more importantly, the problem is that you apply a particular RF energy. If it's one species of gas that is there, you know what is the RF energy that you have to apply for it to become plasma. When I show you, you will see that exactly after a particular RF power, it becomes a plasma. Now if you try to do the same in air, normal air, you don't know, there are a lot of constituents, there is oxygen, there is nitrogen. You cannot fix a particular RF energy level for the plasma to form. So it's very random. That is why we need a vacuum system. Okay, we have a vacuum system. First we take out all the air that is there in the chamber. So that is the baseline. We create vacuum. Once we create the vacuum, what we do is we let in our air or our gas species for which we are going to create plasma. In this case, it is oxygen. So what we do, we create vacuum, sufficiently large vacuum, using the vacuum pump here. Once the vacuum is of satisfactory level, you let in oxygen into the chamber. At that point, you can see the pressure increasing. Initially, when you are creating vacuum, pressure will drop. Then you can see the pressure increasing because the oxygen molecules are coming in. So the oxygen molecules come in, so they fill the air. Now it's a more definite chamber. You know that this chamber is now constituted most 99% of oxygen. So it is controllable. Especially in such systems, the amount of robustness is measured by how well you can control the system. Okay, how much of the control of the system is in your hands. So that is why the system is designed in such a way that you can exactly tune your system to perform in the way you want it to perform. Okay, so we have a chamber, we create vacuum inside it, then we let in oxygen air into it. After this, what we have to do is we have to apply RF power. So RF power is just basically applying up electric potential in the gaseous mixture through radio frequency coil. So inside the chamber, there is a coil that is around the chamber. The chamber itself is made of quartz glass, and there is a coil outside the quartz glass that supplies voltage into the gaseous mixture. Okay, and this is RF energy transmission. So it's like a wireless energy transmission to the oxygen species, and it starts becoming plasma. Then what we do is we will slowly increase the RF power, and at one point of the RF power it becomes plasma, and you will start seeing a glow. After that, when you increase the power, the glow becomes brighter and brighter. Okay, that shows the energy of the plasma that is getting stored, energy that is getting stored in the plasma, and the etching power or the cleaning power of the plasma. Here, one thing to notice, you cannot indefinitely increase your RF power, because there is always a tripping point on any device. It will just get tripped. Another thing that to notice, this is radio frequency plasma generation. So it's about transmission lines. Okay, so in transmission lines there is this idea called forward power and reverse power. So you have, it's called through impedance matching, you deliver some power at a frequency, RF frequency. Here it is 13.56 megahertz. At a particular RF frequency, you are delivering power to a load. Now because it is a energy that is transmitted over a frequency, there is always a reflection of energy that happens, that is measured using this reflection parameter gamma. You might have studied earlier in your engineering time. So there is a reflection that happens. Now this reflected power goes back to the system that is supplying the power. Now if that reflected power is more, it creates current within the system that is supplying power and can cause burning of the wires and all that is connected. So our design objective is to always reduce the reflected power and make sure that the forward power or the delivered power only is maximum. So when we will show you how we have tuned this system to deliver maximum forward power and minimum reverse power. And these are the fine things that you need to take care while you operate the system. So we saw that we have a chamber, we vacuum it, we fill oxygen inside it, then when we apply RF power inside it, okay, and plasma gets created. Before all this, you have to load your substrate inside, because before you close your chamber, you have to load your substrate inside. Then you do all these things. Then you keep it for a defined time, and the substrate gets cleaned, and then you take it out. This is the overall operation of the plasma chamber. Now we will get into individual blocks of the actual system and let's see whether we can create plasma. So now we are going to the fun part. Let's try to operate the system and create plasma in the oxygen plasma system. So as I'm just repeating, we have the main system here. I will get into details of each of these interfaces soon. So we have the main system here. I will go into details about each of the system, each of the subparts of the system later. So to this system is connected the vacuum pump. This is an oil based vacuum pump. It's a rotary pump, and the pump tube from which the air is sucked out is this. It is connected to the main system. Okay, and then the power to the pump comes from a main supply unit on this board. So we just need to connect the power supply cord of this vacuum pump to this main unit, and power will come to that from the main unit. Okay, and then we have the oxygen cylinder here. So from where the oxygen supply goes to the main unit. So for demonstrating to you, we have kept the oxygen cylinder here, but as per safety regulations, oxygen cylinder should be kept outside the lab in a utility room, properly chained. But because we have to show you that cylinder connection goes like this, we have kept it here. This is not how it should be operated. So oxygen tube is connected there, and supply will go. Okay, so these are the three main things that are required for the system to operate. So now let's get into understanding the main chamber and oxygen plasma main system. Okay, I have not powered it on. Before I power on, let me show you what are the individual components of this. So main, the heart of it is where we actually use it, is the chamber. This is the chamber. Okay, it's a magnetically sealed chamber. So I am pulling it. So there is a magnet here and here. Magnetic attraction is there, because of which it gets sealed properly. This is a chamber. Let's zoom into the chamber now. So now we have zoomed into the chamber. You can see it is a 2-liter volume chamber. The dia of this is around 3 inches. 4 inches actually, almost 3.8 inches, and then the volume is around 2 liter inside. Now if you see, look closely, you can see a coil that is running around it. There is a coil, that is the RF coil. We supply RF energy, we transfer RF energy to the oxygen through this coil. Okay, that is the RF coil which creates the plasma, and if you look at the end of it, you can see some holes. So that is those are the holes through which air is sucked out. There is a big hole. That is from where air is sucked out by the vacuum pump. There are 2 small holes, right? Those are gas inlets for giving 2 different gases. This system allows for giving 2 different gas inlets. So you can have a mix of 2 gases to create plasma, which is sometimes useful. So 2 gas inputs are there. Then finally there is a vent port through which you can vent. So those are the inside, you can see the ports. Now let's zoom out. Now this one is the interface panel, which is a touch display where we switch on and we can see how to control the things. Now this one bottom is the RF control port. These 2 what do you call it, indicators are the flow indicators for the gases. This is gas in A and gas in B. I told you that there are 2 gas inlets. For each of the gas inlets, there is the flow indicator, flow meter here. We can see what is the flow rate at which the gas is coming in. Okay, and we can fix it by controlling the knob here. Okay, now this is the RF control. I told you, right? Separately, if you want to switch on the RF, you have to power on it here, and you can set the RF power. What is the megawatt power that you want to give? What is the RF power that you want to give, that you can fix through this knob. And I told you that the return power has to be minimized. Only the forward power has to be maximized, should be maximum. So that return power minimization is done through this tune and load. I told you also that reflection is dependent on the load. Depending on the load value, the reflection parameter changes. So your load has to be adjusted so that it is equivalent to whatever typical load that you will place inside your chamber. And depending on adjusting the load and tune values, you can have minimize the reflected power and maximize your delivered power or forward power. Okay, this is the RF power. After all this, any such equipment will have a safety button, safety stop or emergency stop button. So that is emergency stop button here. This, if you pull, the system will shut down immediately. Okay, let's turn on the system now. You can see the system booting once it powers on. Yes, we have powered it on. So it is booting, system is booting. Starting, and you will get the interface. Okay, now the interface is on. Now we need to switch on the plasma control also. So I am switching it on. You can see here the plasma control coming up. That sound you can see, and you can see a display on the plasma control. that is 150 watt forward power and the RF is off. That is the overall status. 150 forward power and off. That is maximum RF power that it can deliver and off state. Right now we are not touching this. Now let's look at the interface. So if you look at the interface, there are a lot of things that are there, and I will tell you how to operate that. Now the first thing, as I told you, is to create the vacuum inside the chamber. Correct. Now if you see under the vacuum tab, you can see that the pressure is 189140 Pascal. Okay, so that is like it is at normal atmospheric pressure. Okay, and the vacuum is not created. Now left of it you can see the options: turn on pump, turn off pump. That this pump is a vacuum pump. When I click turn on pump, this pump will turn on and start sucking air out or creating vacuum inside the chamber. That time you will see this pressure dropping. It will drop to tens of pascals. Okay. First step for us when we are trying to make the plasma is that we'll switch on the pump and we will see the pressure dropping to tens of pascals from 188,928 Pascal. Okay. Once that is done, next part for us will be to the gas inlet. We have already connected gas. We have switched on opened the gas cylinder, oxygen cylinder, but we have not opened the valve for the inlet of the gas cylinder inside. So we have to open the valve for the gas cylinder. That will be our next step. That is here. So there is separate controls for gas 1 and gas 2. We have connected our oxygen to gas 1. So once we have created the vacuum, next step for us is to let the oxygen come in. Okay. So once the oxygen starts coming in, you will see the pressure going up again. That is because the oxygen that we are pushing in is reducing the vacuum that is being created. That is an indication that the oxygen is actually going in. I am just telling you. So we create vacuum by turning on the pump. Then we will see that the vacuum will go down. Then we will open the inlet for the oxygen. The gas will come in. As the last step, second last step is we switch on the RF power. When we switch on the RF power, you can see the RF power that is delivered. Here it is showing as 150 watt. That we will control from the knob below, which I showed you earlier. We will see it again. Now I will turn on RF power. You can see the RF power that will be delivered. We will keep it at around 50 watt. Okay. Then as we adjust the RF power, we will start from very low RF power, and we will see at some RF power the plasma getting created. Okay. Once the plasma is created, we can leave the plasma for some time to act on the substrate. First off, we will not put a substrate, we will just create plasma and see. Then we will put a substrate also and see. Once your cleaning action or bonding action is done, cleaning is done, then the next step is already oxygen is inside, right? You have to vent out the oxygen and remove the vacuum that is created. So that's last valve is to open air. Here open air option is there. That will open the air in outlet valve and allow the air to come in, basically, because it is vacuum inside. So air will come in and expel the oxygen out. So that is these are the main controls for the plasma to form. On the right side are some programming options where you can time your clean. Like you can say that I want to clean for 5 minutes. So you can time your clean and the plasma will be on for 5 minutes and then it will shut off. Okay, and there are some other options also which are not really important. So this area is a major part for us to create the plasma. Okay, as you can see, there is a small sound that is coming. The RF system is on, but we are not actually delivering any power. So let's do the first step. We have to switch on the pump. It will take out the air from inside the chamber. Okay, so let's do it. I am going to turn on the pump. I am going to click turn on. So you can hear the sound of the pump operating. Okay, now you can see the pressure dropping here. See, it is rapidly dropping. 19,000, 18,000, 1,000, 600, 400, 300, 200, 100, under 100 now. The pressure is dropping continuously. Let it get down to under 10 Pascal. Then we will switch on the oxygen supply. So from 188,400 Pascal, immediately within like 2-3 seconds, it has come down to 24 Pascals. Okay, let's wait till it comes below 10 or at least in the range of 10 Pascals. So as you see, okay, when this happens, I will explain something else to you. So while this comes down, I will explain some very a small interesting thing to you. So as you see, as you saw that the pressure Pascal value dropped very rapidly from that very high value to a reasonable low value of 100 Pascals. But after that, it takes lot of time to reduce 1 by 1 Pascal. Why is this so? This is because when you start off, what is vacuum creation? It's basically you are removing atoms and molecules of different gases from the milieu and taking it out and creating an empty chamber ideally. Okay. So as initially when there are a lot of molecules, it is very easy to take them out because there are enough number of molecules to take out. Imagine that you are swimming for fish in the ocean and the fish are the molecules. If there are a lot of fish in the ocean, you just throw your net, lot of fish will come when you start off. Okay, so next time in the same ocean, if you try to catch fish, the number of fish has reduced. So if your goal is to make the number of fish in the ocean 0, it becomes more and more difficult for you to remove that remaining fish because they are very difficult to come by, because it's a vast space and the fish are very less in number. So the vacuum pump has to exert more energy to extract that last remaining molecules that are creating that defined pressure. That is why the pressure drops from very high value to a reasonable low value quite fast. Then after that, going below each Pascal is difficult because it becomes increasingly difficult to extract molecules from that milieu because they are very less in number. You have to put work on the system to take out that molecule. They have to search for that molecule and take it out. That's why it takes time. So now let's see what is the pressure it has gone to. So the pressure has dropped to 10 Pascals. Okay. Now it's time for us to let in oxygen. So when I switch on the oxygen, open gas 1, you can see, you observe the pressure there. The pressure will increase because of the oxygen that is being pushed inside. Okay. So I am going to press open gas 1. So we have pushed in oxygen inside. You can see the pressure slightly increasing. Okay. So you can see that it is increasing. It has become 22-23 Pascals. Okay. So I will not keep it that much. I will reduce it a little bit. We will keep it to 15 Pascals. Okay. That control I am doing using the flow meter below, which I had shown you before. Okay, so I have kept it at 20 Pascals. This is when with the oxygen in. Okay, to confirm that this is what is happening, let me just close the gas valve now. Okay, that means we are not supplying gas, so it should again go back to the low pressure. So I am closing the gas valve. I have closed the gas valve. You can see the pressure will drop from 22 Pascal. Slowly it will drop. Yeah, 21 has become 20. Slowly it will become 19 Pascal. It takes some time, as I explained before, to reduce that molecules. See, it has become 19 Pascal. So like this it will reduce. We don't have time to show you that much. So I will open the gas valve again. Okay. So I have opened the gas valve again. So we have set the flow. So it will go back to again that value of 22 or 24 Pascals of oxygen. Okay, so we have kept oxygen is there. Okay, some defined amount of oxygen is there at some pressure. It's difficult to control it. So now this shows that there is oxygen. Okay, now we have created vacuum. We have allowed oxygen to come inside. So next step is to switch on the RF power. Okay, so let's switch it on. I'm going to press turn on RF power. So I have turned on the RF power. Okay, so we have turned on the RF power. Okay, now you can see the chamber and you can see the control. Okay, now in the control you can see that forward power is 0 and the return power is also 0. Okay, let's now focus on the RF control. Okay, now we are looking at the RF control. Now it is 0 forward watt and 0 return watt. Now this is the knob to adjust the RF power. So let me increase the RF power. 1 watt forward, 2, 3, 4, 5. So return power is not there. So this is good condition. So it is tuned properly. Okay. Now let's. So like this, I will keep increasing the RF power. Okay. Now you will not see here. Now let's look at the chamber where the fun happens. Okay. Let's zoom in on the chamber. So now we are looking at the chamber. Okay, now RF power is 5 watt. You don't see anything special happening inside the chamber right now, correct? Now let me increase the RF power. Now it is 6 watt, 7 watt, 8, 9. I am slowly increasing it. It is 15 watt now, forward power. But the return power has become 12. So I need to adjust it. Okay, now you can see slight pink color coming in the chamber. So you can see a light pink color coming in the chamber. Now that is at 15 watt RF power. Let me increase the power. 16, 18. You can see that the intensity of the plasma is increasing. So I will increase and keep it at 50 watt RF power. You can clearly see the plasma inside now. It is pink in color. This is the oxygen plasma that has been created. So now you can see it properly. Pink color plasma inside at 36 watt RF power. I will make it. I am tuning it. Whenever return power comes, I will tune the RF control. So this is at 50 watt RF power and plasma is ready for you to work on the substrate. Okay, you can go up to 150 watt power, but that is not really necessary for our operation. This plasma is enough to etch the surface or clean the surface. So I think you can clearly see the plasma inside, pink color. Now let's see if the plasma goes away when I reduce the RF power. So I am just going back. I am reducing the RF power. Just look at the chamber. Keep looking at the chamber. Okay, I am reducing the RF power now. You can see the intensity going down. And when I go to 0 power, it will become that plasma will get extinguished. Now the plasma is gone. Plasma is gone and we have come back to a no plasma state. Okay, now that we know, so we have seen the plasma. Now how do we switch off the system? Now first thing, so what did we follow? What is the sequence that we followed? We created a vacuum, we let oxygen inside, then we switched on the RF power. Then we saw the plasma getting formed. Now we will switch off the RF power first. Okay, so I am turning off the RF power. Okay, now we are turning off the RF power. That is the first switch on procedure. Turn on the RF power. RF power is turned on. Next, what you have to do? You have to close your gas supply. So I am closing the gas supply. Gas supply is closed. Now you have to switch off your pump. because you don't want to pump it. Pump is switched off. You can hear sirens. The pump is not working now. Now, but we have created vacuum inside, right? The vacuum level is still quite low, but we want to use it immediately. So we can vent air into the chamber. So for that we have to go here. Air valve closed is there now here. In that we have to put open air. Now you can hear the air coming into the chamber. So parallelly you can see that the pressure here has become back to the high value. Now you are ready to open the chamber. Now we are ready to open the chamber, and we are opening it. We are able to open it. We can go inside and see. It will not be hot because this is RF energy. Next step, we will try to clean a glass substrate and a PDMS membrane and see if we can bond the two. That is also another application of oxygen plasma. Okay, so that we will do now. In another a minute we will do that. As the next step, we will be bonding this glass slide with this PDMS membrane. You can see the membrane, PDMS, flexible material. So what we will do is we will place both of them inside the oxygen plasma. Both the surfaces will get activated, and then we will take it out from the plasma treatment and see if they will bond. Okay, it's going to be really interesting. Let's do this. Let me keep these two inside the chamber. Okay, so we are going to place the glass slide inside the chamber. So the slide is placed. Now we will flip and place the surface which we want to bond, nicely cleaned, inside. It's better that you keep it sufficiently inside. And the PDMS and the glass should not be one above the other. It should be separated so that both gets treated by the plasma properly. Okay, now I have kept both of them inside. I am closing the chamber. Now we will do the same thing that I did before. You just look at the chamber. We will create plasma again. So what I will do, I will switch on the system. Okay, first I will turn on the pump. So the pump will create the vacuum first. Now we will wait for it to go below 20 at least. So I am waiting for the vacuum to be sufficiently large. So in vacuum, if you try to open the chamber, you won't be able to open it. It is tight, air seal. Oh, but you can actually connect here only. Oh. So we have created the pressure, vacuum. It is 9 Pascal. So now we can open the oxygen supply. So oxygen is coming in. I will let it in. So you can see the pressure has increased because of the oxygen input. Now we will switch on the RF power. Yeah, now we have switched on the oxygen supply. Now we will turn on the RF power and keep it at around 50 watt. So we have kept it at around 65 watt. So the plasma has been formed. Let's look at the chamber. So now we are looking at the plasma. It is at 65 watt power. You can see the glass slide and the PDMS membrane inside soaked in the plasma. We need to do this plasma treatment for like 5 to 10 minutes. After that we will take it out and see how they are bonding. Okay, you can nicely see the pink color plasma bathing the slide and the PDMS membrane inside in the plasma. Okay, so we will after 5 minutes we will take out these two and try to bond them. So now we have done around 10 minutes of plasma treatment on the glass substrate and the PDMS membrane. Now we will follow the taking out process or the bonding process which we will try after we evacuate the chamber. So let's first switch off the plasma, then I will close the gas vent. I will make the plasma voltage to 0. Then I will turn off the pump. Okay, I have turned off the pump. Now I will vent it. So I have vented it, everything done. I can even switch off the system now. I have switched off the system. Now we will open the chamber, take out the samples carefully. I have taken it out, and I will try to keep the surfaces that have been plasma treated on top of each other. Okay, so I have kept the PDMS membrane and the glass substrate on top of each other. The surface that was exposed to the plasma is touching the glass slide of the PDMS membrane, and the glass slide's surface that is treated as touching the PDMS membrane basically. So I have kept both of them together and they have bonded.
Started from there bonded.
So I have kept both of them together and they have bonded. You can shake it and see they are not coming out, they are nicely bonded. Okay, so this is what, so this way we can make microfluidic channels on this PDMS membrane and bond it with a glass substrate that has sensors and without using any glue. This is the advantage of using plasma bond. Okay, so we have bonded it nicely. Okay, I hope you understood the resourcefulness of this tool and you found this module useful. Thank you. I hope you found this tool to be quite resourceful and you understood the various uses of this tool and how it forms an integral part of the microfabrication sensors and actuators course, and how it is important for developing systems that sense physical changes in phenomena. You can go over the video again, understand the concepts that we have discussed while trying to understand how a real world system works. We have even looked at how we were installing it, what are the individual components of the system, how each component is important. So this is one example of how a system is tested from box to working condition, and through that journey you also understood the concepts that are involved in it and how it fits well with the idea of sensors and actuators. We'll be happy to see you in the next module. Till then, thank you.